Okay, welcome back, AP Physics Mechanics students. We're going to do our second lesson in a little bit on differential equations, but before we do that, I want to review first some properties of exponentials, because the next topic, the next day of differential equations, the next lesson will be very heavy on exponentials. So I want to just make sure everyone understands how the exponential works, and also what its derivatives are and what the integrals are of the exponential. So the first thing, we have a simple y equals e to the negative x. If you plug in 0, e to the 0 gives you 1. And as time goes on, we have e down in the denominator. 1 over e to the x is what e to the negative x is. So as x gets bigger, the function y gets smaller and smaller and goes to 0 as as x approaches an infinite value. We call this exponential decay. If it were e to the positive x, it'd start at 1 and rise, and that would be like an exponential growth. Okay, but the negative power is primarily what we're going to be using, and that starts at 1 and goes to 0. Now, so an interesting thing you could do is, if you want something to rise from 0 instead of to fall to 0, you could just make a new function, y equals 1 minus e to the x, because e to the minus x, as we just said, starts at 1 when you plug in 0 and goes to 0. So that term starts at 1 and goes to 0. So when you do 1 minus that, what you have is something that starts at 1 minus 1, which is 0. And then as this x goes to infinity, we go to 1 minus 0. So it goes from 1 minus 1 to 1 minus 0, which is 1. So you flip the pattern around by doing 1 minus, and then it rises to 1 instead of falls from 1 as x goes to infinity. Okay, so that's a very important thing we're going to be using a lot in the next topic. Okay, and here we are with some features of the exponential. If you have e to the x, and you take the derivative of that, it's just e to the x. A very interesting function. Its derivative is the function itself. If you have something like this with the power inside the exponential, e to the minus bx, the derivative of that, because of the chain rule, is just the e to the x function, e to the minus bx function, but then you have to multiply that e to the x by the derivative of what's inside here. So the derivative of negative bx is just negative b, and that's why that negative b is in the front. That's how you take the derivative. If you integrate e to the x, if y is e to the x and you integrate that, again, it's an interesting function. The answer is just e to the x, the original function. And of course you have to evaluate over the limits. But if you have e to the minus bx and you integrate that, then what happens there is you have the original function, e to the minus bx, but instead of, in the case of the derivative, multiplying by what's inside, you have to divide by the derivative of what's inside. So the derivative inside is minus bx, is negative b. The derivative of that is negative b, and then you divide by that instead of multiply for integration. So there is just a brief review of the exponential function. You could jot this down if you want, but you don't have to. You could just, if you remember that and you think you've got it, then that's good. And we're going to use that information for the next lesson, which is coming now.